As space enthusiasts continue to wait for the inevitable takeoff of SN9, SpaceX has made some bold moves as of late, purchasing a couple of abandoned oil rigs off the coast of Texas. Elon Musk has long talked about the prospect of floating launch platforms, especially considering the danger zone that the Super Heavy would represent and the enormous amount of noise that it would create, and it seems that he's following through with his plans. He got these rigs for a mere $3.5 million apiece, which is an absolute steal. But while this is a very interesting development, my mind, while I'm waiting for SN9 that is, tends to wander towards the future, towards Mars, towards getting humans to Mars, and how the Starship is going to be able to do this in a realistic amount of time, at least when it comes to large numbers of passengers. And I continue to conclude that a different sort of propulsion is ultimately going to be necessary if Elon really wants to send 1 million people to Mars sometime this century. And while I just made a video about nuclear thermal propulsion, I have to ask, is there a way to go even faster? Is there a way for us to turn months into weeks? Well, as a matter of fact, there is. Using current nuclear technology and without using anything like fusion or antimatter or anything like that, we can conceivably reach Mars in 2 weeks or less. Yes, you heard that right. 2 weeks worth of exposure to cosmic rays and radiation, only 2 weeks worth of supplies, which would make taking large numbers of colonists a much easier task. So many advantages to getting to Mars in this amount of time. As a matter of fact, you could make multiple round trips using the same ship in the same launch window. And even more incredibly, this same system would put Jupiter within our reach in a mere 2 months. Now obviously going to Jupiter would not be a great idea given the huge amount of radiation it generates, but its moons of Ganymede and Callisto are outside of its radioactive influence and are excellent targets for the human species. But how is all of this possible? With something that I like to call the ultimate nuclear rocket, and there are actually a couple of designs that qualify in my opinion for this title, and we're going to learn all about them in just a few minutes. Good evening and welcome to another episode of the Angry Astronaut. So, am I going to go and rant like I did during my last episode, at least the one that wasn't a live stream? Well, probably not quite so much. This is more of a futuristic episode, one that doesn't piss me off quite as much as other topics. But still, it really does annoy me. Anytime I talk about the field of alternate forms of propulsion, I usually get very angry. And the reason for this is we've been working on alternate forms of propulsion, particularly in the field of nuclear propulsion, for over half a century, with virtually nothing to show for it, except now we're just on the cusp, I hope, I pray, of getting nuclear thermal propulsion as being a practical form of drive. But is nuclear thermal the best that we have at our disposal with our current level of technology? Well, the answer to that, of course, is no, and I have discussed other forms of propulsion using nuclear power with our current technology on this channel in the past, although it's been quite a long time. However, there's a couple of forms of propulsion that I haven't discussed. Forms of propulsion that don't involve containing a nuclear reaction. That's one of our biggest problems, isn't it? It's one of our biggest problems with nuclear reactors here on Earth. Containing the nuclear reaction and making sure that it doesn't present a hazard to anybody close to it, in this case, crew members, that sort of thing. But what would happen if you could propel a ship without really containing the reaction? That is to say, use the reaction to propel the ship and have the reaction take place behind the ship. A lot of you can probably guess that I'm talking about Project Orion, that's been around for an extremely long period of time, that involves, to be blunt, exploding nuclear weapons behind the ship to provide it with propulsion. And believe it or not, that could actually work, and it's actually gone through a lot of evolution. But there's another form of propulsion that also involves a semi-uncontrolled reaction taking place directly behind the ship that was created by the highly controversial Robert Zubrin. People have been asking me over and over to do a video about this subject, so I'm going to cover both of them, and I'm going to cover both of them right now. Now, I'm going to start out with the most controversial of these rockets, and although you might think that exploding atom bombs behind a ship would be the most controversial, it isn't. Instead, it's Robert Zubrin's brainchild, the nuclear saltwater rocket. So here's how the thing works. First, you dissolve low-grade uranium, 20% grade, which is used in some types of reactors, in an aqueous solution, in other words, water, and then pump it through a pipe that's lined with boron carbide. And the boron carbide absorbs neutrons, preventing this solution from hitting critical mass too early. The solution then hits a reaction chamber, which has no boron carbide, and then a nuclear reaction starts. It hits critical mass, essentially, but it's surrounded by water, which acts as a moderator, keeping the reaction from getting too hot. And at the same time, the water's traveling at about 66 meters per second, which drives the exhaust, or the nuclear reaction, out the nozzle. So the rocket is propelled by the nuclear reaction. The results are pretty unbelievable. Whereas a nuclear thermal rocket superheats the propellant, something like hydrogen for example, and sends it out the nozzle 2 to 3 times the speed of a chemical rocket, thus giving it about 900 to 1200 seconds worth of use, or ISP. The raw power of a nuclear reaction would provide 10,000 seconds worth of ISP, over 20 times the efficiency. Oh, and by the way, about 3 million pounds worth of thrust, or 60% that of a Falcon Heavy. That kind of efficiency would produce incredible amounts of delta V, and on top of that, about 3.5 G's worth of acceleration for about 3 hours, or almost 3 hours, which means you would need to engage the engine a number of times over the course of the mission in order to not kill the crew from high G forces over a sustained period. In addition, others have criticized that the neutrons would not be as easy to control as Zubrin suggests, and that it's quite possible that neutron radiation would feed back into the engine, melting it down and possibly causing hazard for the crew as well. Of course, the only way to test this is in space. Either way, this rocket would produce an enormous amount of neutron radiation from the exhaust, and you wouldn't want to be behind it unless you wanted to commit suicide in a rather unfortunate and painful way. But still, look at the image that you're looking at right now. Imagine seeing Jupiter growing in your field of view bit by bit over the course of only 2 months. as opposed to the insane amount of time that it would require conventional rockets to get human beings to this planet under current circumstances. This rocket would be a complete game changer if we could solve the problems. The fuel is one problem because even though water obviously is abundant and cheap on Earth or even on Mars, uranium-235 is not. However, you can use isotopes like uranium-233 or plutonium-239, which is far more abundant and cheaper. And of course, if you have a lot of water and a lot of radioactives like uranium, you can also have a small nuclear reactor on the ship itself to provide electrical power for the vessel, for the life support and other vital systems that will be necessary, especially if you're hauling large numbers of passengers. The reactor would be something similar to what we use on submarines, utilizing water as moderators to keep the chain reaction from getting out of control and to produce only the amount of electrical energy that you need. But how would you make this system work with the Starship? No, calling this thing the ultimate nuclear starship was not just clickbait. I really do intend to tell you how to make this system work with the SpaceX flagship vehicle. First, the Starship would assemble the nuclear engine in high orbit. It would be necessary to put it together in a very high orbit beyond low Earth orbit, simply because it would be putting out so much radioactive exhaust once you activated it. Once this was done, then the Starship would deploy itself in the typical fashion, using the Super Heavy and the Starship itself and refueling to reach the necessary orbit to rendezvous with the rocket. So really, the Starship itself remains unchanged. The Super Heavy, the use of methalox, the refueling process, all of that remains standard. However, once the refueling process is complete, that's when things change radically. The nuclear saltwater rocket would essentially become a nuclear tug. The engine itself would weigh about 33 metric tons, and the fuel would be about 83 tons. So you'd be looking at about 2 Starship missions in order to assemble the entire thing. Once this was accomplished, this tug could push the entire Starship, all 200 tons of it, at the speeds that I've been talking about, 3.5 Gs for almost 3 hours, giving incredible amounts of delta V and the short transition times that I've been discussing. But you would have to have it as a separate entity, not as part of the Starship design. And so the tug would push the Starship to the desired delta V and then decelerate the Starship into Martian orbit once it arrived, detaching from the Starship once the vessel was in orbit. Obviously, you would not want this engine to attempt re-entry along with the Starship itself. Instead, you would leave it in orbit for another mission. But what happened if there was some kind of problem with the engine? If it got damaged during the transition or required maintenance? Would this be done in orbit? Well, the answer is probably, although in theory the engine could first jettison its uranium fuel and then re-enter the Martian atmosphere using an inflatable system that is both a combination heat shield and re-entry system similar to what NASA is working on right now to bring the engine down to Mars for more extensive work, although it would probably be easier to just do it in orbit. But regardless of the details, what Robert Zubrin has come up with here is a method using current science, current physics, and current technology to get us to Mars within a couple of weeks. and at a level of acceleration that's the same as somebody experiences when taking off with the space shuttle or perhaps on the Crew Dragon and maintaining that acceleration for hours instead of a few hundred seconds. It sounds like something out of science fiction, but it isn't. You would think that this would be the ultimate nuclear rocket, but as you're about to see, Project Orion really gives it a run for its money. Now, a lot of you have probably heard of Project Orion, but it really is a very remarkable idea. So remarkable that the US government actually spent $85 million in today's money on the idea of exploding small nuclear weapons behind a vessel in order to perform sort of a pulsed type of propulsion, rather than an ongoing nuclear reaction, as is the case with the nuclear salt water rockets. As you can see from this animation from Asteronix, this money was spent back in the 1950s, and it was actually spent through 1965. Washington was actually quite serious about this idea until the Nuclear Test Ban Treaty prevented these kinds of ships from being created. As you can see from the diagram, the design calls for very small nuclear weapons to be detonated a short distance behind the ship with shock absorbers to absorb the plasma shock wave generated by a small nuclear weapon, and the shock absorbers would transfer the momentum to the vessel itself. The bombs would have a tiny yield, only 0.15 kilotons, and would be fired behind the ship at a very high rate of speed by a Gatling gun type of device. So the rate of the pulse would actually be quite high, and the rate of acceleration in delta V would be equally high. Now, believe it or not, back in the days when we used to explode nuclear weapons on Earth on a regular basis, we were actually thinking of using this system to take off, but fortunately that's been abandoned in recent times, and now of course this kind of ship would be assembled in orbit, but it would have to be pretty damn huge, and it would be able to carry cargoes of 1,000 tons or perhaps even more, and it would require all of this for the most part because you would need lots of protection for the astronauts. Exploding nuclear weapons directly behind a ship generates so much neutron radiation that it requires an enormous amount of protection. However, the crew quarters would be quite spacious, and the ship would be a lot more like a submarine than it would be like a rocket. It would be constructed out of very heavy materials rather than aluminum and carbon fiber like conventional rockets. It's a totally different type of design. And you don't have to construct it out of heavy materials just for the protection of the crew. In addition to that, the ship has to endure the shock wave of multiple nuclear explosions, hundreds of them as a matter of fact. You're not going to get that out of lightweight materials. And so there's a lot of things about this ship that requires a great deal of mass to be carried to orbit. One of the reasons why they were looking at using nuclear explosions to launch the damn thing, just because chemical rockets would have to haul up so much mass. With the advent of the Starship, however, you could conceivably now haul up enough mass to build something like the Orion. And by the way, if you want to take the design to its craziest extreme, Freeman Dyson, remember him, the guy who designed the Dyson Sphere? He came up with a much larger version of this ship, 100 meters in diameter, weighing 400,000 tons. And it would be so wide simply because it would be rotating, producing artificial gravity. And it would travel at 1g acceleration for 10 days until it got to 3.3% of the speed of light, and then coast for 133 years to Alpha Centauri. Obviously, a generation ship. Not to be outdone, Zubrin has his own version of a generation ship for his saltwater rocket, utilizing a C-class asteroid and all the water that it would have on it. A 30,000-ton asteroid with 7,500 tons of highly enriched uranium, in other words, weapons-grade uranium, to propel 300 tons worth of spacecraft up to 7.62% of the speed of light and arrive at Alpha Centauri after a 60-year journey. Now, all of this is well and good, but where the hell are you going to get all of this fissile material, and how are you going to deal with all the radioactive waste that it's spewing all over the solar system? Well, first of all, scientists suspect that most, if not all, of the uranium in the solar system is on small rocky planets like Mars and Earth. But in addition to that, there's an asteroid called 16 Psyche, which is the remnants of a protoplanet, and spectrographic analyses of this asteroid indicate that it has a lot of uranium, as in thousands and thousands, if not millions of tons of uranium on it. The fuel for these kinds of rockets are actually quite abundant in the solar system. And if you're worried about nuclear waste, you must remember that our own sun is nothing less than a gigantic thermonuclear weapon of epic proportions that's spewing radiation all over the solar system. Only our magnetic field provides us with protection along with our atmosphere. Other than that, radiation is everywhere in the solar system. So what are a few nuclear rockets really going to add to that? So what is the ultimate nuclear starship? Well, as you can see, in my opinion, it's the saltwater rocket. And the reason for that is it's an ongoing detonation that provides about 3.5 G's worth of acceleration as opposed to nuclear blast after nuclear blast. The Starship, as it's constructed, is designed to withstand 3.5 G's worth of acceleration, which is about the same as its Raptor engine's supply. Therefore, a tug equipped with this kind of rocket could indeed drive the Starship to the type of speeds we've been talking about and bring science fiction into the present, if we have the boldness and the ingenuity and are willing to spend the money on such a crazy concept. In my opinion, it's worth the risk. So, obviously, both of these systems, or all three of them, or whatever you want to call it, given how many different changes Orion has gone through over the years, have significant drawbacks, the most significant of which involves spewing lots of radioactive waste all over the cosmos. Now, of course, this is the sort of system that you wouldn't want to use anywhere in the vicinity of a planet. Although in theory, you could use something like a saltwater nuclear rocket to take off, although it would leave a massive nuclear crater in its wake and would probably be a violation of a lot of strategic arms limitation treaties. But in theory, it could work. All of that having been said, obviously, this is not something that we would do. This is something that we're going to want to do as far away from Earth as possible, in an orbit more distant than low Earth orbit, preferably, maybe the moon, something along those lines. But nevertheless, I think it's something worth investing in, because the mere prospect of getting to Mars in 2 weeks, Jupiter in a couple of months, it's a total game changer when it comes to exploring the solar system. And Orion, the same way, it can accomplish similar things. And of course, also the prospect of generation ships getting to Alpha Centauri in a couple of generations, that sort of thing, assuming that we become desperate enough to go after that sort of goal. Still, very, very exciting prospects that I am seriously disappointed that we're not investing in. And of course, we're not investing in it because we can't test it. We can theorize, we can do simulations, but we can't do practical testing here on Earth. It would spew out so much radioactive waste. It would be Chernobyl times 10 at the very least. It's not the sort of thing in the past, of course, we used to test nuclear engines here on Earth, but things have changed a lot in terms of our regulations in this regard. So the only way to test it would be in space, which means you would have to invest a lot of money before you could even initiate these tests. Is it worth it? Well, let me tell you something. We just invested, we as in the United States, over $15 billion in 2020 just on updating our existing nuclear arsenal. That's more than 75% of what we've spent on the SLS. The entire damn project from beginning to end in 1 year. So if we're willing to spend that kind of money on weapons, on methods of killing each other, which we've been very willing to do, the amount of money we used to spend on nuclear weapons during the Cold War completely dwarfs what we spend on them now. Why are we not willing to invest that kind of money on the possibility of exploring the solar system in a far more practical manner? Getting to Mars in 2 weeks instead of 6 months, 2 weeks of microgravity, radiation, cosmic rays, and only 2 weeks worth of supplies, which is perhaps the most important advantage. Why not invest in this sort of technology if it has even a decent chance of working? And there's nothing in our current technology and our current understanding of physics to say that either the nuclear saltwater rocket or Orion would not work. I think it should be at least seriously explored. And thus far, aside from the drawing board, we really haven't done anything, at least in the last half century. And it's absolutely time for us to change that. And not just in terms of nuclear propulsion, photonic propulsion. There's so many different ways of getting to other planets in the solar system that's so much more efficient and so much safer for our astronauts than this damn method that was antiquated back when we started sending out rockets to the moon in the 60s. Let's hope that we do so. So, if you like these sorts this sort of programming, you like this sort of futuristic content, and you just like my mannerisms, whatever, there are a lot of different ways to support this channel in the description. Please have a look or just throw me a like and a subscription. I'll be very happy for that. Once again, thank you so much for 45,000 subscribers. I am now shooting for 90,000. I guess I like to shoot high, but when I had 20,000, I didn't think I'd make it to 40 so quick, and yet I did, so I'm going to give it another shot. And by the time I reach 90, I'm going to give you a show that makes blowing up a mug look like an absolute sideshow. This is going to be spectacular. So get ready, because I'm going to be exploring this further in the days to come. So until we're willing to seriously invest in very aggressive forms of propulsion that will take us throughout the solar system and beyond, I urge all of you to stay angry about space.